Alright, in this section we're going to talk about independent and mutually exclusive events, except we're not going to talk about mutually exclusive events, so we'll just do independent events. This corresponds to the book section 3.2. Last section we talked about concept of probability and how to calculate different probabilities. This section will talk about two sets that are related in a certain way. In particular, they are independent. When we use the term independent, let's say I'm an independent person, that means my decision is not depend on other people's decision. I do make my own decision. So that's one way of saying that you're an independent person. Kind of same idea here. A and B are independent events if the occurrence of A, I'm going to delete this, there's a little typo here, sorry. The occurrence of A does not affect the probability of B occurring. For example, suppose I flip a coin and a die at the same time. Like, they don't know each other. One doesn't affect the other one, right? So if I flip a coin and flip a head, it doesn't affect the probability of rolling a 6 on your die because they don't talk to each other. So in that case, I can say these two events are independent events. Maybe I can give you another example. Let's say I have a friend James who's taking a class. I ask him, hey James, what's the probability you're gonna get an A on your next exam? And he's like, well, I've been studying a lot, maybe 70%, right? Okay, that's fine. But I ask him again, hey, what's the probability you're gonna get an A given that it's gonna rain that day? And he's maybe the type of person who gets affected by rain. He's like, oh yeah, then I'm gonna be in bad mood, somehow I can perform well. So it's gonna be only 60%, right? So in this case, the probability of getting an A was 70%, but probability of getting an A given that rain has occurred is only 60%. See how the probability changes and they're not equal to each other? That means rain affected the probability of getting an A, so they're not independent event, right? Not independent. However, let's say I have another friend, Cindy. Maybe she doesn't get affected by rain too much. So I ask her, hey, what do you think you're going to get an A on your exam? What's the probability you're going to get an A on your exam? She's like, oh yeah, 70%. She's been working hard as well. And then I ask her another second question, just like James. What's the probability that you're going to get an A given that it's going to rain that day? And she's like, what does it even matter? I don't get affected by rain, so it's going to be still 70%. So 0.70. So for her, these two events are independent events because the probability stays exactly the same. Probability was not affected by the rain. So more systematically, we can check two events are independent or not. So either I can check probability of A given B is equal to probability of A. Probability of B given A is probability of B. Notice that it's the first event that their probabilities are equal to each other. The third one, we don't use it as much, but this is another formula you can check. Probability of A and B is same as probability of A times probability of B. Most likely we'll use the first two more often to figure out if two events are independent. So in this case, we can't just argue, oh, they're not affected by each other. We actually have to show number, calculate these two probability, and say these numbers are either equal to each other or they're not equal to each other. That's how we're going to determine whether two events are independent or not. Okay, I'm going to have you pause, work on number 3, and we'll meet back at number 4. Alright, for number 4 and 5, we're going to look at the concept of independency in terms of sampling. So kind of like depends on how we sample. We're going to say our sample is independent or dependent. So when we sample without, we'll look at number 5 first. When we sample without replacement, means once you're selected, you will not be selected anymore. Not be selected anymore. Did anymore. So once I pick you as a sample, that's it. I'm not going to pick you again as a part of the same sample. Where when we sample with replacement, this means it's possible that somebody can be selected twice. Someone can be selected multiple times. Because replacing means I pick you, survey you, and put you back into the pool. So for the next one, by chance, if you're picked again, then you're part of my sample again for the second time. So that's the difference between sampling with replacement and without replacement. If I do with replacement, you're going to have the same chance of being selected all the time, so it's going to be independent. If I do without replacement, then once I pick you first, then you'll not be, then the probability of you being selected the next turn is 0. So your probability changes, so it'd be dependent sampling. For a lot of questions, when they say, oh, we're going to pick 3 people, or we're going to pick 5 items, or whatever, they're not going to say it's either with replacement or without replacement. They're just going to say we need to select 5 people. In that case, by default, we're going to assume the selection will be without replacement. Because it kind of makes more sense when somebody says I need 2 people, you pick the first person and I pick the second person from the rest of the class. Not necessarily I pick the first person and put this person back into the pool and try to pick the next person where this person can be picked again, possibly. So, okay, I'm going to have you pause and work on number 6. We're going to skip number 7 when we'll meet back at number 8. Okay, we're back at number 8. Conditional probability again. This gives you just alternate way to calculate conditional probability. Again, when I see probability of A given B or A bar B, I can interpret this as probability of A given B is already happened. One other way to interpret this is probability of A out of B. So let's see, this is given B. I can also interpret this as out of B. Depends on the situation. So the formula here is probability of A given B is equal to probability of A and B on top. And if it's out of B, that's on the denominator of the fraction. So on the bottom, I'll see this. So the second part goes to the bottom, and then A and B is on the top. So sometimes, once in the future, a few times, we're going to utilize this formula to calculate probability of A given B. You can skip questions regarding mutually exclusive. So skip mutually exclusive events. So for example, this is asking, number 9D is asking if they're mutually exclusive, and also part D of number 10 is also. So you can skip that, and then you can skip that. That concludes our worksheet.